morning. Today is 20th March and now we are going to start a new topic. The topic is radical number. Radical number, and the exercise is on page number 55. Exercise is on page number 55. Radical number. So we are going to begin radical number. First of all, we need to know what is radical number. The first thing that we are going to see is what is radical number. This will be the first question today. Radical number. What is radical number? Okay. So it is a number, any number with root sign. With root sign is called as radical number. A number with radical sign, right? Radical means root sign. Radical sign means root sign. A number with radical sign is called as radical number. Very clear. Now, this radical sign, we have infinite radical signs, right? This is not only for square root. Normally, commonly we use a square root sign, but this radical number can be of any type. There are infinite type of radical signs, right? It is square root, right? This is cube root, then fourth root, then fifth root, then sixth root, and so on. All these are called as radical sign. These are all called as radical sign. Is it okay? And this radical signs will contain a number inside it, right? Suppose here this is A, then here also I can write the same number, write the same number here also, and this. Now, when you write it exactly in this form, then this root A, right, as a whole, this is called as radical number. This is called as radical number. This is one example. Similarly, this also is a radical number. This is a radical number. This is a radical number. This is a radical number. So all these are a radical number. Right? This is, as a whole, it is called as radical number. In this radical number, as I told you that these are radical signs. These are radical signs. Is it okay? So this part is called as radical sign. This part is called as radical sign, right? And the number within the radical sign is called as radicand. Is called as radicand. Is it okay? So this is the basic information about what is radical number, and in the radical number, which part of is called as radical sign and which part is called as radicand. So the root signs, the square root sign, the cube root sign, the fourth root sign, fifth root, sixth root, this is how we read it. Square root. Actually, same like this other root signs. Here in this root sign we have 3, right? A small number 3 in the V shape. Here we have 4, small 4. It has to be very small. Please be mindful that this 4 has to be very small. If you write a big 4, then the meaning will change. This is fifth root. We will call this as fifth root. This is the 5 in the small space inside the V area. This is 6 in the V area. So this is how we write the radical signs. This is cube root. This will be read as fourth root. This is read as fifth root. This is read as sixth root. And this one is read as square root. No? And here also we have actually 2. Same like other radical signs. In this also we have 2. But what happens is, this is very, very commonly used, right? And therefore, even without writing also, we understand that there is a number in that small V shape, which is true, but because it is well understood, it is commonly understood by everybody, that is why we do not reflect and you will not find 2 written anywhere in any of the textbook, or no teachers will teach you that there is a number 2. But yes, for information I am sharing that there is one unseen 2. Okay, obviously there is a 2. So these are all called as the radical number, and in this radical number, I have taken one example where there are 2 parts of this radical number. One is the sign part, another is the number part. So the sign part is called as the radical sign, and the number part is called as the radicand. So this was the basic information of radical number. Now we will have the next topic in the radical. We will continue with the type of radical number. After we have understood what is radical number, now we are focusing on the type of radical number, right? So there are 3 types. We will classify them into 3 types. The first one is called as complete radical. Complete radical. Another one we will call as mixed radical. Second one we will call as mixed radical. Mixed radical. Right? And third one we will call as the whole number. Whole number. Okay? Now complete radical means what? A number with just a root sign. A number with just a root sign. Example, root of 32. Right? This is a complete radical number. Or root of 1000. Right? This is a complete radical because you have just a radical sign with a number. That's it. Therefore, this is said to be complete radical. Very easy to understand. There is nothing else with this. So it is called as complete radical sign. Now, the mixed radical. Here we will have the mixture of the whole number and the radical number. So mixture of whole number and the radical number, we call it as mixed radical. Is it okay? So the one example is 3 root 13. This is one example. Now here in this case, you can see the difference between these two. Why this is called as complete radical and why we call this as mixed radical. This will make you more clear after these 2 examples. This is called as mixed radical because here we have whole number part and we have radical part. Since we have mixture of the whole number and the radical number, and that is why we call this as mixed radical. Is it okay? Then we can have some more example. 7 root 13, 7 root 12, right? Any number we can take. This also is a mixed radical because here we have mixture of the whole number and the radical number. So we call this 2 as mixed radical and this is called as complete radical. In the previous topic, when I taught you what is radical number and what are the different type of radical number, if you remember, I told you that you can write cube root and then 4th root and 5th root and 6th root. So if you write cube root, right, then we write this as cube root of a. And I told you very clearly that these 3 has to be a very small in size and it has to be within this small V shape. Okay, then this will be taken as cube root. Clear? But if this is written big size and in front of the radical sign, then that meaning will become different. Then that 3 will be taken as a whole number. That 3 will be taken as a whole number. This is the example. Here I am writing this 3 big size and it is out of the V shape. That means this is a whole number. This is not in the radical sign. This is not with the radical sign. This is a whole number. Right? That is why since the size is big and it is out of the small V shape, so it makes it a whole number. Whereas this 3 is a very small 3 and it is inside the small V shape, then this makes it a cube root. So this is very important how you will write. If you make a small mistake in writing this, then the meaning of this will change. After all, this is mathematics. Here even a point also plays a very, very important role. Now the whole number. Whole number, very simple, everybody knows. This is a whole number this is a whole number, this is a whole number. No? So this is the type of, these are the three type of radical number. Complete radical, where there is no whole number, only a root sign with a number inside. Only the radical sign with the radicand is called as complete radical. And here we have a whole number and we have the radical number also. This is called as mixed radical. And then in the last case, we have only whole number. So these are the three type of radical number. The next topic we have is changing radical sign into exponent. Every radical sign can be converted into exponent. Exponent means power. Power means degree. Clear? So we are going to learn how can we change this radical sign into exponent, because sometimes when applying this, when solving the question, you may have to use this skill. Therefore, we will learn how can we change the radical sign into exponent. So first of all, let us have some example. The square root of a is a radical number. A cube root of a is another radical number. Fourth root of a is a radical number. Fifth root of a is a radical number. Sixth root of a is a radical number. I think this one example will be enough. If we can learn changing these radical signs into exponent, then we will not make any mistake. This will give us a very clear understanding and a very good concept. Okay. Now, also there is a purpose of writing this. When I am writing, you might have noticed that I try to write very carefully. This 3, the size of the 3 has to be the size of the number in front has to be very small. No, here I was writing little big because so that it can be visible to you. Okay, but still I made it more small. We will read this as cube root. We will write this as cube root of a. This will be read as square root of a. Now same thing, if I write this 3 bigger in size, then I will read this as 3 root a. See how the meaning changes, right? If with the size of the number in front of the root sign. If the size is small, it will be read in a one way, and if the size of the number in front of the root sign is big, then it will be read in a different way. Okay. So this is one radical sign, root a. This is cube root of a. This will be read as fourth root of a. This will be read as fifth root of a. This will be read as sixth root of a. So this way we have also learned how to read this radical signs, radical number. Very important. Now we are going to move on to how to change this radical signs into exponent. Okay. One thing we need to remember, the basic thing that we need to remember is when you are changing a radical sign into exponent, into power. When you change the radical sign into exponent or in power, all these powers will come as a fraction number. When a radical sign, note, I will give you the note. Let me write a little bit more left side. Note what? When radical signs are expressed as power, then the powers will be always a fractional number. Always a fractional number. This is the one thing that you have to keep in mind, right? When these radical signs are converted into power, then the power will be always a fraction number, right? With 1 as the numerator. always a fractional number having 1 as numerator, 1 as numerator. It's not very clear. I will rewrite this. Numerator, right? We're having 1 as numerator and denominator shall be denominator shall be denominator shall be the number in front of the root sign. Number shall be number in front of root sign. Okay, now it will make your work very easy. How do we, this is the step that we have to follow for changing this radical sign into exponent. First of all, before I actually do it, I will read the instruction. When radical signs are expressed as power, then the powers will be always a fraction number in which 1 is numerator and denominator shall be number in front of root sign. Denominator shall be the number in front of root sign. So now look here. How do we change this into power? I am going to do now. You write the radicand and then give the power. Now when you are changing this into power, I told you that this power will be a fraction number where numerator is always 1. And for any kind of radical sign, in the fraction the numerator is always 1. Right? Denominator what? I told you the denominator will be the number that is in front of the radical sign. And this is square root, and here I told you that here the number in front of the root sign is actually 2. So therefore we will write this as 2. So this is how this radical sign is converted into power. Next one, this now. After this, now you are comfortable, you can write the exponent. Here also the numerator will be 1. And what could be the denominator? Is it 3? It should be 3 because this is the number in front of the radical sign. Because this is the number in front of the radical sign. And the denominator shall be number in front of root sign. So this is the number in front of the root sign, therefore this is the denominator. Now by this you might have understood everything. So this will be next. Now a to the power 1 over 4. Likewise this will be a to the power 1 over 5. This will be now a to the power 1 over 6. Right? If I have one more last nth power, nth root of a. If it is nth root of a, then in that case it will be a to the power 1 over n. That's it. Clear? Now we are at the verge of starting the exercise, right? And just before starting the exercise, let us know one more concept and then we will start the exercise. And that concept is how to simplify the radical quotients. Any quotient of this exercise, how are you going to simplify? So for all the quotients of this exercise, there is only one method of solving, right? We need to simplify the radical quotients through factorization, through prime factorization. Through factorization, or we can say prime factorization. Through factorization, we can solve this any quotient through factorization. Through factorization. Is it okay? Now when we say through factorization, then there are two methods of factorization. One is called as a prime factor method, another is called as a general method of factorization. prime factorization or general factorization. We can use any one of these two methods, whichever method you are comfortable with. We can use any one of the two methods and then we can solve a radical question. With this, I am going to start the first question. Now, after this, I will request each one of you to keep, always when you are watching this video lesson, must keep the textbook in front of you. You can understand more faster, and then same time, right after the watching video, you can also practice the questions. Question number 1. Question number 1. We are in page number 55. Page number 55. Okay, the question is, first question is, write each radical in simplified form. Write each radical in simplified form. In simplified form. Is it okay? So the first question is A. Root over 48. Root over 48. Now, I told you that this question we can do it by prime factorization method or we can do it by general factor method. Right? It's up to you how you want to do. If you are doing it by general factor method, then what we can keep in mind is what kind of root sign is this. Okay? To see the type of root sign is very important. Since the root sign is square root. What? The root sign is a square root. So when you factorize this radical, because the root sign is square root. So when you factorize this radical, you keep in mind that you factorize this 48 in such a way so that your one factor should be a square number, should be a perfect square. This is what we have to keep in mind when you are doing it the general factor method. Factorize this 48 will have many pair of factors. Example, you see now, 48 factors can be 1 into 48, 2 into 24, 3 into 16, no? 4 into 12, right? 6 into 8. So these are all the possible pair of factors, right? Now, in which pair of factors you are getting the perfect square? And that also we will look for the biggest perfect square. In this pair, we have a square number, and that is 1. 1 is always everything. 1 is God, 1 is everything. So we don't consider that one. Other than that one, 2 into 24. In this pair, do you have any square number? No. In this pair, do you have a square number? Yes. This is 16. So this can be 1. This one, yes, here also, in this pair also we have a square number, 4. And in this number, we don't have any square number. So these are the two pair of factors you got, in which you are getting one factor as a square number. And here also you are getting one as a square number. Now, out of this 16 and 4, which one is the bigger square? Obviously this 16. Therefore, we will finally choose this pair of factor. I told you we will solve every radical question by factorization. This factorization can be general method of factorization or by prime factorization method. Right now I am doing it by general factor method. So after writing all the pair of factor, then we are selecting the pair in which we have the biggest perfect square number. And therefore this 48 can be replaced by this pair. So this can be written as 16 into 3. Right? Why do we choose the perfect square? Because this is a root sign. This is a square root sign. And if you choose the perfect square number, then the square root of this can come out of the radical sign. And then this is how this can be reduced. This can be simplified. Right? The purpose is to simplify. That means to write this in the lowest form. So this is 16 and this is a perfect square number and its square root will be 4. Therefore, since this is a square root, there is a square root of this number. That is why it will be eligible to come out of the radical sign. So 16 came out as 4 and then remaining, this number will remain inside the number because it does not have the authority to come out. And this is your answer. Hope this is clear. Let us see one more example. Root over 1000. Root over 1000. Is it okay? Now root over 1000, again you have to factorize. Same way, right? Bigger the number, you will have more number of pair of factor, right? So every time you don't need to do, this was just a beginning, that is why I gave you. If it is necessary, you can do the rough work. Otherwise, if you think you can do mentally also, fine. And then this number I am going to factorize. So this is a very simple number, though it is big, but it is a very simple number. When I factorize it, I can write this as 100 into 10. Okay, because the product of these two is 1000, and out of this 100 is a perfect square number. Therefore, its square root can come out, and this can be reduced into the lowest form, and therefore your answer will be 10. The square root of this 100 will be 10. So that 10 came out, and the rest will be inside the root sign. This is 10, and this is your answer. Clear? Then another one more question is number C, cube root of 32. Very good. Cube root of 32. Now this time it is a different radical sign. It's good to practice different type of questions, different radical signs questions. These two were a square number, these two were a square root, these two questions were a square root. That is why when you are factorizing, you are looking for a perfect square number. But now this is a cube root question. So for the cube root question, we will look for perfect cube number. Please get the difference. These two are the perfect, these two are the square root question. That is why we have looked for the perfect square number. Now this radical sign is a perfect, it's a cube root. This radical sign is a cube root, and therefore we are looking for a perfect cube number. A perfect cube number. Is this okay? So when this is perfect cube number, you can do it by prime factorization method. That will be more better. Perfect cube root questions can be done by prime factorization method. For your convenience, it will be easy. So let us factorize this 32. This is 32. This 32 we are doing it by prime factorization method. So you know how to do the prime factorization method. 2 16s, 2 8s, 2 4s, 2 2s, that's all. So this 32 is factorized, right? Now this 32 is factorized, and it is written as cube root of, we will rewrite this as 2 to the power, how much? 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5. Clear? Since this is when it is cube root or fourth root or fifth root, then better to do it by prime factorization method. It will be easy for you. Now what we are going to do? We have expressed this radicand as an exponential number. Clear? Now we are going to split the power of this number according to this root sign. Please keep in mind that this number, this radicand will be, the exponent of this radicand will be splitted according to the root sign. Here, because the number is 3, this is a cube root. Therefore, when you split this power, you will split this power as 3 and then something. So we can write this as cube root of, this will be written first because the power of one of the base has to match with this one. 2 to the power 3. That means out of 5 power, 3 power came out. How many power of 2 is left? 2. So then you can write another factor as 2 to the power 2. Hope this is very clear. Now after writing it into this form, then you will take this as a perfect cube number because the power of this number is 2. So this will be seen as perfect cube number, and therefore it will be able, the cube root of this number will be able to come out. Clear? The power of this is 3 or multiple of 3. So therefore it will be, the power of this 2 is 3 or multiple of 3. Then this will be said as perfect cube number, and therefore it can come out of the root sign. When this comes out of the root sign, the power of this will be divided by 3. Clear? So this 2 to the power 3 comes out, and when it comes out, the power of this 2 is divided by this 3. So this 3 divided by this 3 will be equal to 1. Therefore the cube root of this number 2 to the power 3 is only 2, and rest will be remaining inside only. So this we can write this as not in the form of 2 to the power 2, we can write this as 2 to the power 4. 2 to the power 4. This is your answer. Is it very clear? There is one more question in D. This is root over 110. Right? Now this number you try to do it by prime factorization method or by general method of factorization. When you do it by prime factorization method, it's better you do it by prime factorization method. When you do it by prime factorization method, you will find that it cannot be simplified. It cannot be reduced. I will show you. It cannot be reduced. This 110 we are trying to do by prime factorization method, right? 1, 1, 0. So let us do. This is divisible by 2, so it becomes 55. Then this is divisible by 5, then this is 11, and this is 11 and 1. So that's all. Now you can see here when you have done the prime factorization, all the factors are coming in single. No, you are not getting that into pair. If you get this factor into pair, only then you can say that you have got a perfect square number. Is it okay or not? So this can be maximum written as equal to 2 into 5 into 11. We did the prime factorization method, but not a single factor is in pair. Therefore, this nothing can come out of the root sign, and therefore this question remains as it is only. This cannot be reduced more. Now we are moving on to question number 2. Question number 2. This question number 2 is arrange the following in ascending order. So we have some different type of radical numbers, and we are asked to arrange them in ascending order. Now when you look at this radical number, this is a mixed radical number. Again, every time I am repeating, when you write the number in front of the root sign, you have to be very mindful, because if you write the number very small and within the V shape, then it will be read as cube differently, like it will go with the root sign. Then that number will go with the root sign. And if you write that number bigger in size in front of the root sign, then it will be a separate number from the root sign. So here, this is a mixed radical. This I am reading as 3 square root of 13. This I read as 4 root 7. This I read as 9 root 2. This is a whole number, and this is 6 root 3. So we have different type of number. How can we arrange them? How can we arrange? Right? Because some of them are whole number, some of them are mixed radical number. No? So this is very difficult to arrange them in ascending order in this format. Therefore, in order to do this, what we have to do is, we will convert all this radical number, all the type of radical number in the same format, Is it okay? So the more easy method will be, the best method is to completely change them into radical number, in the radical form. We will change all these terms into complete radical form. If we can change all this into complete radical form, then we will be able to easily understand and arrange them in ascending order. Now, if you have all the numbers in the same format, then it is easy for us to arrange. Like if I say 2, 5, 7, 9, no? Then this type of numbers, if I ask you to arrange them in ascending order, none of you will have difficulty. Because, not because the numbers are simple, is because these are all of the same type. So when we have of the same type and the numbers are of the same type, we are comfortable arranging them in ascending order or in descending order. So first of all, we are going to see how can we convert them into complete radical form. So we are now going to learn a new skill of how to convert any kind of radical number into complete radical form. Okay, so one by one. First of all, this is 3 root 13. We will change this into complete radical form. Okay. You know that if you have a perfect square number inside the radical sign, if you have a perfect square number in the radical sign, then it can come out in the form of a square root. Inside the radical sign, if you have a perfect square number, it will come out of the root sign as a square root. Right? Now, if the number outside the root sign wants to get inside the radical sign, then it has to be squared, opposite of that. When it comes out as a square root. And when it will go inside, it will go as a square. So, you just follow this process and it will be done. So, this tree wants to get inside. To change this into complete radical form. So, it has to be squared. Therefore, we will write this as the square of this tree is 9. And then this is 30. Clear? When you multiply, this comes as a root over 117. Now this is the complete radical form. This has come from here only. Okay, so remember. Next one is 4 root 7. 4 root 7. Now here also we will change this into complete radical form. The number that is in front of the radical sign, it will be squared and will then enter. So square of 4 will be 16. 16 into this number as it is 7. Clear? Now multiply this, it will come as 112. Next one is 9 root 2. Now this mixed radical also wants to be a complete radical number. So the number outside the root sign will enter inside the root sign. So it will be squared. So 9 square will be 81 into these two as it is equal to, now simplify, this will come as 162. Clear? Another number is just a whole number. It's only a whole number. But this also we will convert into mixed radical number. Right? So what we can do is, here we don't have any square root number with it. No worries. You can create the radical sign. Right? You can just square it and then put it inside the radical sign. So there is no any other partner of this one. So we will write this as square of 11 is 121. Right? And here this will remain as is only. In one step only, we could convert this into complete radical form. Last one is 6 root 3. 6 root 3. This is equal to, now square of 6 is 36 into 3. Right? So this is how much? 6 3 are 18 and 6 3 9 1 10. This is your complete radical number. So all this mixed radical number now we have converted into complete radical form. And you can now, because all these numbers are of the same type, square root of 17, square root of 112, square root of 162, square root of 121, square root of 108, all the root signs also are same. The advantage is all the root signs are same. If the root signs are different, then we can't do that. So when the root signs are used same, then now we are able to look at the radicand and check which one is greater and which one is smaller. The question is to arrange them in ascending order. That means first of all we have to choose the smallest number. So the smallest number is this. I will number this as 1. Then the next bigger number is this. This is number 2. Right? Then the third number is this. This will be number 3. Right? Then the next number is this. This is number 4. And then the last one is this. This is number 5. So done. Now we can write them in ascending order. Okay? So I will write here. The first one is 108. Right? And this 108 has come from this number. So no need of writing this one. We can write this one because actually I should have written first of all this, and then in the next step I could have written in this format. But because I have only this much of space, so I will directly write the solution. So the smallest number is this. This is number 1 and it came from here. Therefore 6 root 3. Right? When you are arranging them in ascending order, you will use the less than sign. Please remember, when you are arranging in ascending order, you will use less than sign. Now number 2 is root over 112. 112. Now next, third one is root 117. Then less than. Next one we have is number 4 is root 121. And then last one we have is root 162. Sorry. This we are writing in terms of this, no? So again I will correct. Okay. After 6 root 3 less than, then number 2 is 112, and 112 has come from 4 root 7. 4 root 7. Then number 5. Number 3 is this, and it came from 3 root 13. 3 root 13. So this is 3 root 13. Less than. Now number 4. Number 4 is 121 and it came from 11. So 11. And then last one is this, which has come from 9 root 2. Done? This is your question number 2. Now we are moving on to question number 3. A very simple question. Simplify root 18 and root 45. Very simple question. Root 18. Root 18. I told you that every radical question will be simplified by factorization method. Okay. So for all the questions we are going to use the same method. I am going to write the prime factor or the general factor of this radicand. Right? It depends on you how comfortable you feel. For me, I am going to use the, because the number is very simple, I can use the general factor method. and I can factorize this number. When you factorize this number, please be mindful of the root sign. This is a square root. Therefore, when you factorize this number, you must keep one factor as a square number. Square number. So I can factorize this as root over 9 into 2. Is the product of 9 and 2 is 18? Yes. And 9 is a perfect square number? Yes. Therefore, this square number can come out in the form of a square root, and therefore your answer is 3 root 2. Done. Very simple. Next number is root over 45. 45. Now this also will do in the same way, right? We can have many pair of factors, but then we have to choose only one pair of factor in which you get a perfect square number. So here I am factorizing this also as 9 into 5. No? You can do some rough work and also you can finalize. For me, I am doing it directly. And now we can, this is a perfect square number, this will come out, so this is come out as 3, and then root 5 will remain as it is. So this is how we have simplified this question. Is it very clear? Now, this is part A of question number 3. Then there is a part B also of this question. Let us conclude this question number part B also. Now, the question says you have to use the result of this question number A and find the solution of root 18 into root 2. Okay. Using this result, using the result from part A, you have to find the solution for this. Okay. So we will do this now. Root 18, we got it as equal to how much? We are using the result of this question, 3 root 2. So for root 18, now I can write this as 3 root 2. And then this into root 2. Is it okay? See how interesting it is. This 3 is as it is 3 into. You know very well that root 2 into root 2 is what? Root 2 into root 2 is always equal to 2. Isn't it? Why? Because when you convert this radical sign into power, for this 2 it will come as equal to power half. For this also it will come as to the power half. Isn't it? Now you can use the exponential law, the product law. When the bases are same, the power can be added. So you take the common base and add the power. Half plus half. When you add it, it becomes 1. 2 to the power 1. And therefore we write this as 2. That is why this root 2 into root 2 is always equal to 2. Similarly, root 3 into root 3 will be only 3. Root 10 into root 10 will be only 10. Root 100 into root 100 is equal to? Thank you. So this is 2. And therefore finally answer is 6. Is it okay? There is one more question in that same. Root over 45 divided by root over 5. Now we have to use the result from the part A. From part A we have got the result of this root 45 as 3 root 5. So we can replace this by 3 root 5 divided by root 5. How interesting it is. These two will cancel. Answer is 3. Done? So this is the end of the day. We have done. We have understood the concept of radical number, and also we have done up to question number 3. I will request all of you to please just practice till question number 3 for the day, for today. But do not leave any question from 1 to 3, right? You can do it repeatedly because you have more time in place of going out and putting yourself into problem. Better you stay in the house and practice these questions. Thank you so much.